Alright, let's look at the homework 4.2, 4.3, problem number 3. Alright, so let's use Gauss-Jordan elimination to solve this system of linear equation. Right? So first I'm going to turn this into a matrix. So it's a 4, negative 14, negative 2, and 86 on the right hand side, and a 1, negative 4, 0, and you have 24 on the right hand side. Right, so first I would like to turn 4 into 1. So easiest way would be switch R1 and R2. Right, so you're gonna get 1, negative 4, 0, 24. Right, then you have 4, negative 14, negative 2, 86. Right, again, sorry about the noise. Right, now we have 1 here. Right, now we want to turn 4 into 0. Right, we can do that by take row 1, multiply by the negative of the number we want to get rid of, then add it to row 2. Then that's going to be our new row 2. Right, so let's look at that. There's no change in row 1, so I'll copy 1, negative 4, 0, 24. Right, so let's 1 multiplied by negative 4 added to 4 is 0, which is what we wanted. Right, negative 4 times negative 4 is 16, added to negative 14 would be 2. 0 times negative 4 is 0, added to negative 2 is negative 2. Right, 24 times negative 4, so that's what, let's see, 24 times 4 would be, 4 times 4 is 16, and 4 times 2 is 8, so it's a 96 with a negative sign. So 86 minus 96, so it's a negative 10. Right? And next thing we want to do is we're going to turn this guy, which is the leftmost non-zero element, we want to turn it into 1. And we can achieve that by dividing row 2 by 2. So let's do that. Right, again, nothing happened to the first row. I'm going to copy 1, negative 4, 0, and then you have 24. Right, so 0 divided by 2 is 0, 2 divided by 2 is 1, negative 2 divided by 2 is negative 1, negative 10 divided by 2 is negative 5. Right, now we have leftmost 1. We have to make sure that everyone else has to be 0. So we have to turn negative 4 into 0. Right? So we can do that by take row 2, multiply by positive 4, added to row 1. That's going to be our new row 1. Alright? So let's find the new matrix. So the new matrix is going to be, right, nothing happens to the second row, so I'm going to just copy the second row as it is. Right, so we're going to do, so this 1 doesn't change. 1 times 4 added to negative 4 is 0. Negative 1 times 4, negative 4 added to 0 is negative 4. Right, so negative 5 times 4 is negative 20, added to 24 is positive 4. Right, so this is in reduced form. So we know that we can rewrite this equation. So this equation is x1 minus 4x3 is equal to 4. And second row, it would be x2 minus x3 is equal to negative 5. Right? Then solve this equation for x1. We can get x1 is equal to, by adding 4x3, we get the 4 plus 4x3. And here we can add the x3 to get x2 is equal to, let's see, x3 minus 5. Right, so therefore, the solution, there's going to be infinitely many solutions. But in this case, x3 is the free variable, so it's t. And I will say where t is any real number. Alright, then once you have t for at x3, x1 is 4 plus 4t, x2 is t minus 5. Alright, so let's type it in. Alright, so we got the x's, x1 is, right, 4 plus 4t, and here x2 is, that was t minus 5, so t minus 5, and x3 would be our t. Right, so let's check the answer. Right, whoops. Reduce, let's see, real number. Alright, so maybe I'm using a different, oh, sorry, I'm putting in the wrong place. That's what it is, sorry about that. So this was right here, 4 plus 4t, and t minus 5. Alright, let's check the answer. Alright, got that. Alright, that's it. I hope that this was clear.